Hi, all. Good morning, good afternoon, and good evening, depending on which time zone you're viewing this talk from. I'm Divya, Engineering Manager, leading developer productivity and quality team at Netflix. Today, I'll be talking about next generation automation framework for TV that is being built, which is based on Puppeteer. My talk will broadly be split into three parts. First, context setting and what is Puppeteer, followed by why Puppeteer and how we enable something that is for browser to TV, and lastly, demos and the magical possibilities the next generation framework is unlocking for us. So let's get started. So, what is Puppeteer? Puppeteer is a modern web browser automation solution that brings the power of web to Node.js, providing easy to use APIs to navigate to pages and control the browser. Some of you might already be familiar. Puppeteer is an open source project maintained by Chrome DevTools team. It's a node library that provides high-level APIs to control Chrome over Chrome DevTools protocol, CDP. Breaking it down, Node.js and JavaScript are backbone of the most web applications and familiar to most developers. And the high-level APIs, they're a human-readable interface for interacting with web pages through Chrome using CDP, the standard protocol that allows for tools to instrument, inspect, debug, and provide Chrome. So why Puppeteer for browser automation? Puppeteer has been quite popular in the recent times as it adopts Chromium principles, and it is simple. The APIs are easy to understand and debug. It's stable, not flaky, and doesn't leak memory. Secure, it operates off process with respect to Chromium, making it very safe. And speed, it has zero performance overhead over an automated page. So what's special or unique about framework that we built then? We're not web. We need an automation solution for TV. So how do we base it on Puppeteer then? Let's find out. So I'll dive into the crux of the talk by describing how we achieved this and what additional changes we incorporated to build a robust next generation automation framework. The building blocks are the first and foremost is CDP, the Chrome DevTools protocol, which enables us to communicate with the application and helps perform test automation, tracing, troubleshooting, profiling, and instrumentation. The second is implementing Puppeteer APIs that are compliant with open source. Again, open source is very heavily tied to the browser and we are like a TV platform. And third is adding support for widget queries to be same as web-like, and enhancing with adding test attributes for selection, and also enhancing our page object model. And tying all this together, we use Jest to write and run these tests in. So let's go into the details of each building block. The protocol was implemented by a platform team that allows for tools to instrument, inspect, debug, and profile the app. CDP allows for remote control of application by sending JSON messages over WebSocket. CDP exposes low-level automation primitives that are non-flaky and low overhead. These primitives are close to how user interacts with the application, which in turn unlocks unlimited automation capabilities. So here is an example. The client creates a WebSocket to connect to the URL and start sending CDP commands. In this example, we're getting back the performance metrics. Next building block that we have, now that we have a way to control the app, was to provide convenience, which is by implementing API-compliant implementation of Puppeteer, which works with the TV platform. Again, to reiterate, we can't use the open source library directly as is because their implementation is heavily tied to browser APIs, events, DOM, etc. Our Puppeteer interface implementation intentionally makes use of the open source TypeScript definitions so that all open source documentation, blog posts, conference talks can be applied to our code base. To call out, we are a superset of open source APIs, as in addition to the all familiar page.go to URL to navigate to URL, page.wait for selector to wait for a particular selector to be on screen, page.mouse input APIs, we expanded that set with custom APIs that is beneficial for us. For example, here what I've called out is page.get platform metrics to get like the custom performance metrics is very specific to TV app. Do note that the custom API names are subject to change. Another building block that is again straightforward in browser with the CSS selector that defined element to which CSS rules apply, we had to add support for querying widgets so that it can be more web-like. So we can use the all familiar dollar, 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 and also more powerful queries that supported in the web. So here we just listed out some examples. And the next thing is, as we were moving forward and innovating with the new framework, we found opportunity to rethink existing design pattern for page object model and redesigning for enhancing test maintenance and code simplification. Design principles were to keep POM simple, meaning readable, explicit by keeping clean code separation between test, page code, and assertions, designing POM to be powerful by using reliable, stable, non-flaky methods with appropriate wait for methods like wait for selector, wait for request, wait for response, and many other wait for methods that are available in Puppeteer. And also enhancing methods to include key things to be done automatically, like automatic screenshotting, instead of taking screenshots only on failure. By this, we can build a storyboard from the test, automatic test step logging for better traceability, and automatically gathering performance metrics for each action. So a test can be used for function and performance metrics collection and validation, which in turn increases developer velocity by providing developer holistic picture and reducing the need for writing multiple tests. One other important evolution in the new approach is adding test-specific attributes to widgets and focusable widgets. For automation, we need to find select widgets based on certain criteria. We add the test attributes to widgets for selection. More importantly, the benefit that it actually provides is it is decoupled from implementation details that we were tied to before, like we were very tied to the React props in itself. So what is implementation details? These are the things that users of the app will not see, use, or need to know of. So ideally, automation also shouldn't be using them. Users of the application interacts with widgets and contents in the page. Our focus is to set test attributes specifically on the widgets directly. By this, tests are not affected by refactoring or when implementation details change. Here is an example of a test that's waiting for a selector using the test selector attribute. The automation framework, we use Jest as a test runner and testing framework. Jest was already used as our unit testing framework, and having it for Puppeteer tests unifies in one framework and reduces a further friction for developers when writing or debugging UI tests. Now, re-summarizing as to why basing our next generation automation framework with TV on Puppeteer is, it is simple, it leads to increasing developer productivity and ergonomics. Testing is important and should be fun. And all of this is made easy by utilizing Node.js, Jest, and TypeScript. Tests are stable, they have minimal probe effect. For Netflix on TV app, performance and memory footprint measurement is key. And in comparing to our previous framework, it has reduced the automation overhead by at least 10%. Third, to delight our customers, we provide high quality of experience when using Netflix app and performance in terms of key responsiveness. Startup time and memory, in addition to functionality, is key. And with Puppeteer, it's easy to measure and analyze performance metrics. Basing it on open source project provides us API documentation, tech blocks, Stack Overflow posts that applies to us, which means for our engineers, new hires, they can get up to speed to our automation framework in a jiffy. So that was a lot of details. Now let's see it all in action with some demos. Here's the first demo that showcases running a test on our local reference app. Again, we can run this on a local device or remote device, anything that has a CDP support. So here in this case, as you can see, we've set the local to be like true in the browser fetcher. And in launch params, we've actually set the headless to be false, which means it's going to open up the reference application. So what we did was we kicked off the Jest test, and now it's opened up the reference application. And a test account was created and was logged in with the test account that was created. And it went to the profiles gate and from on-ramp to the browse gallery and then to search. And I would search for Daredevil. and it entered the details page, and it's scrolling through all the episodes. And in the test, what it's actually using is all the Puppeteer APIs, like the page.keyboard, page.go to, and it's using all the Puppeteer APIs in itself to actually control the application. And what here it's doing, it's navigating through all the episodes of the show. And what it's also doing is a functional and the performance validation in the background. So that was one quick example. So now let's take one more. So in this case, I'm actually changing the options. So in here, we're changing the launch options to be headless to set to true, which means that it's going to be, we won't be seeing the UI. And the other launch option that we're also setting is dump your flag to be set to true. What this means is we will be seeing all the debug logs actually streamed to the console itself. And so in the headless mode, when it is set to true, the tests actually run like much more faster. And here what we are also seeing is, as I mentioned, we are able to kind of stream the logs. And this is super helpful for any troubleshooting and debugging. And in here, the test was very similar to the previous test it was running. So it's actually running through. It's already it logged in with the account, and it's going to search and it's doing like functional and performance validation. As you can see, it's actually capturing like memory metrics, and it's scrolling through like the different episodes in the show, and all of this in headless mode, which is quite convenient. And again, like in this case, we've actually set the browser fetcher local to be true, but we can also run this like remotely, frankly, like anywhere. So that was, a couple of demos. So next, talking about the future. With the framework we built, it's opened up a lot of opportunities that goes beyond automation. For example, one of the things that we can do is our customer service can troubleshoot, of course, with permission, troubleshoot or control a device anywhere. The other thing that we can do is we can build like a React storybook with interactive app demos. So we have developers who typically don't have like various devices at hand, and our engineers interact a lot with like the designers, product, and many others. With this framework, we can share builds for interactive demos from frankly like anywhere. They can remotely control device like TVs that reside elsewhere with CDP support. The other thing that we can do is we can build Puppeteer recorder that can easily record click events that can be replayed later for quick test creation. We can build online Puppeteer playground so that can be easy for, again, for test creation. We can also record videos of tests that need like some setup early on, for example, like playing 4K content that can later be used for manual verification, removing the need for manual steps, and lots more. Again, thanks for listening, and you can find me on LinkedIn, and here is my Twitter handle. You can reach me if you have want to learn more about the framework or have any questions. Thank you.